Alright, when doing hydrogen NMR, we're going to be looking at a diagram like this, and from this you can see that there's tons of points, or peaks, and they're all grouped together. And we know that our molecule looks something like this, and that it is clearly has two benzenes. With the diagram being so clustered together, we can basically sum this up as one benzene or multiple benzenes. So we're going to go down here. The peaks are too close together to see exactly where they are. So with this benzene over here, these two carbons create a special environment. So we're going to label this group B. So this group is one group. It's the same on the opposite side with this. Since there's a sigma bond, we're not going to count that. And this has one hydrogen, so it's a special environment as well. Going over to this side, since we have a bromine on this side and a fluorine here, these three carbons are one of their own special environments because they are not grouped accordingly like this benzene. So that is how we do proton NMR, is that with benzenes they're too close to tell. We are going to just sum it up as that. Moving on to carbon 13 NMR, it is easier to see where exactly the peaks are, and we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which sounds about right because as in like the other hydrogen NMR, we had 10 groups as well. So we're going to go down here to the structure, and it's pretty much identical to before, exactly where the special environments were from before, primarily because it's a benzene, so it's not a whole lot of options going on. So there's one group here with 4 protons on each. No, oops, sorry, I'm mistaken. There's this, and there's hydrogens on both of these. And this is also in a special environment along with this, this carbon, but we're including this and this carbon. Before we didn't, but now we are for the carbon 13 NMR, because this is based off of carbons rather than hydrogens. And these carbons over here are their own special environment. So this will match up accordingly, since there's 10 special environments and there are 10 peaks. The carbon 13, this verifies what the chart is saying. Backtracking to the hydrogen NMR, since the other one's based off of carbons, this is based off of a hydrogen. So, however this is, there in the special environment right here, there should be a hydrogen and hydrogen, and basically you just count up the hydrogens within a special group, like 2, and then we're going to add 1. This is the n+1 rule, so that should give you 3. And then we will do this for all the special environments and match them up accordingly to how many peaks there are in the diagram. And this will be kind of like the same technique, the n+1, where there are like 3 peaks or 2 peaks that are about the same level, 2, 1, 1. And that's how we do carbon 13 NMR and hydrogen proton NMR.